Hi, welcome to my video on solving exponential equations, part 1. Solve exponential equation. B to the x equals b to the y if and only if x equals y. And the base is not 0 and the base is greater than 0. So if and only if means that if you can reverse it. If x equals y, then b to the x equals b to the y. So you switch them either or. So let's do some examples. Again, you can pause your video and work these out before I do. Solve each. So notice that 2 to the x plus 1 equals 2 to the 7. So the bases are equal, so the exponents are equal. So we let the exponents equal and we solve for x. Move the 1 over, make it a minus. 3 to the x equals 6. Divide by 3, x equals 2. And just to check, if you put it 2, 3 times 2 is 6, plus 1 is 7. Perfect. And again, exponential, both bases are the same, so we can say that 6x minus 2 equals negative x plus 5. Move the x's to the left and move the constants to the right. And when we do, we get 7x equals 7. And we divide by 7 and we get x equals 1. And again, if you put 1 back in, you should verify. So 1 in here, we get negative 1. That gives us 3 to the 4th. Put a 1 here, we get 6 times 1 is 6, minus 2 is 4. So 3 to the 4th equals 3 to the 4th. Correct. Now we need the same basis. So this base is 5, so we need this to be a base 5. So we take 25 is 5 squared. Since the bases are the same, the exponents are equal. And we solve it. 2x equals 2 plus 4. 2x equals 6. Divide by 2, x is equal to 3. And again, check. 2 times 3 is 6. 6 minus 2, 6 minus 4 is 2. 5 squared is 25. And another one. Again, they're not the same basis, so we need the same basis. So 8 is a 2 cubed. 16 is a 2 to the 4th. So we need the same base, so we got a 2. So this is the power of power. So 3 times x minus 2 is 3x minus 6. 1 over x to the 4 is x to the negative 4. Since we have the same bases, the exponents are equal. So 3x equals negative 4 plus 6. 3x equals 2. X equals 2 over 3. X equals, just to make sure, 4, 6, 2, and we have 2 over 3. So if we put a 2 over 3 back in, you can check it. Number 5, and we have a 4. They're not the same bases, so what is the common base between all these numbers? 2. So 4 is 2 squared. 32 is 2 to the 5. 8 is 2 cubed, so we have them all changed. This is the power of power, so this is 2 to the 2x times 2 to the 5. And this is the power of power, so we multiply, we get 2 to the 3x. And on this side, we're multiplying, so we add, so this is 2x plus 5. When we multiply exponential with the same basis, we add the exponents, so this is 2 to the 3x. Since both sides have the same base, that means that 2x plus 5 equals 3x. 2x minus 3x equals negative 5. Negative 1x equals negative 5. Multiplied by negative 1, x equals 5. And again, you can put 5 back in and check to see if it's true. Number 6, we need the same basis. The base is 3 here, so we get an x squared minus x. 9 is a 3 squared. Since the bases are the same, x squared minus x equals 2. We got a quadratic, so we have to move all terms to the left side equal to 0. Quadratic hopefully can be factored, or we got to use the quadratic formula. X and x, factors of 2 are 2 and 1. Product is negative, sum is negative, so we have to have a negative 2 plus 1. Multiply. Negative 2 times 1, negative 2, add negative 1. So that means that x minus 2 equals 0, or x plus 1 equals 0. X is equal to 2, or x is equal to negative 1. So there's two answers, 2 and a negative 1. Again, sub each of these answers in one at a time, and you will get the 9. Okay, let's continue. More practice, trying to make a variety of problems. And notice we're multiplying, so the base is 2 here, so 4 is a 2 squared, 16 is a 2 to the 4, 32 is a 2 to the 5. So let's change them to the same basis first. So 4 is 2 squared, put in brackets. 16 is 2 to the 4, put in a bracket to the x power. 32 is 2 to the 5. So I work the powers first, so that's 2 to the x minus 4 times. Because we've got a power of power, we multiply. 2 times x minus 1 is 2x minus 2. We got a power of a power, so that's 2 to the 4x divided by 2 to the 5. So I did the powers first. Because I'm multiplying, I'll add. And you add 2x plus x is 3x. Negative 4 minus 2 is negative 6. And because I'm dividing, I'll subtract. So this is 4x, subtract 5. And there's the same base of 2, so 3x minus 6 is equal to 4x minus 5. And 4x goes to the left side, and the 6 goes to the right side. So negative x equals 1. Multiply by negative 1, x equals negative 1. Solution, x is negative 1. Again, sub it back in and check it to see if you're okay. And we need same basis, so that's a 5x plus 2, the cubed, third power. 125 is 1 over 5 cubed. 125 is 5 cubed, so that's 5 to the negative 3. And now we have a power of a power, so it's 5. 3 times x plus 2 is 3x plus 6. We have the same basis of 5, so 3x plus 6 equals negative 3. That means 3x equals negative 3 minus 6. 3x is negative 9. Divide by 3. X equals negative 3. And again, sub in a negative 3 and check it out. And you should get 1 over 125. Negative 3 is negative 1. 3 times negative 1 is negative 3. So 5 to the negative 3 is 1 over 5 cubed. Perfect, right? Now we have a base 7, but we need a base 7 here. So that means if I need a base 7, so 1, if the base is 7, 1 is 7 to the 0. So that means that 4x minus 12 is equal to 0. 4x is equal to 12. Divide by 4. X is equal to 3. And to check it out, put a 3 in for x. 3 times 4 is 12. 12 minus 12 is 0. 7 to the 0 is 1. Perfect. 3 is the answer. And number 10 I have here is a little bit different. Notice I have two variables. So let's go with the first equation and go 2 to the x minus y. 2 is a base, so 4 is 2 squared. That means that they're the same basis. That means x minus y is equal to 2. Now we have the second equation. 2 to the y equals 8. Again, the base is 2, so 8 is 2 cubed. So 2 to the y equals, that's a power of a power, so that's 2 to the 3x we multiply. So that means y is equal to 3x. So if we call this the first equation, we can call this the second one. So I'm going to sub y equals 3x into number 1. I'm going to sub. So number 1 is x minus y equals 2. So y is 3x, so x minus 3x equals 2. Negative 2x equals 2. Divide by negative 2. X equals negative 1. And since we have this equation, I'm going to sub x equals negative 1 into number 2. So y equals 3x. X is negative 1. So y is negative 3. So x is negative 1, y is negative 3, makes this system of equations true. All right, again, some variations. And again, we solve the exponential equations in the other units. So let's try some different ones. Now we have these, look, these are different. We have 2 to the 2x power, and this is 2 to the x. So I'm going to rearrange. That's 2. This is 2 to the x, so let's make this 2 to the x. So 2 to the x squared would be the same as 2 to the 2x. Okay, let's do that first. Now I'm going to let 2 to the x equal a. So 2 to the x is a, so that's an a squared. 2 to the x is a, so that's a 5a. Now we have a quadratic in terms of a, so let's solve this quadratic for a and then solve it back in. So we have a quadratic, hopefully it's factorable. A squared is a and a. The factors of 4 are 4 and 1, or 2 and 2. So to get the 5 must be 4 and 1. Product is positive. Sum is negative. It must be a negative and a negative. Multiply negative 4 times negative 1 is 4. Add negative 5. So a minus 4 equals 0. A equals 4. Or a minus 1 is equal to 0. So a is equal to 1. So notice, now we have a, but a is equal to, so that means 2 to the x is equal to 4. A is 2 to the x, so that means 2 to the x equals 2 squared. Bases are 2, so x is equal to 2. A is 2 to the x, so 2 to the x, and we got a base of 2, so 2 to the what power gives me 1, 0. So that means x is 0. So for this system of this equation, not a system, this equation, you got x is 2 or x is 0 as a solution. There's two possible answers. And this is the same one here, very similar to this one. I just did them back to back, because if you ever get it on a quiz, then you'll remember what to do. Again, this is a to the, 3 to the x, so 3 to the x. And this is a, if you put a 2 here, power of power becomes, so 3 to the 2x is the same as 3 to the x squared. Okay. Now we let 3 to the x equal a. You could let it equal y or w or any variable. I'm just picking a. So that makes it a squared minus 2a minus 3 equals 0. So 3 to the x is equal to a, 3 to the x is equal to a, and again, hopefully this is factorable. So I don't have to use the quadratic formula. A and a. Factors of 3 are 3 and 1. Product is negative and sum is negative. Must be a negative 3 plus 1. You have to multiply negative by a positive to get a negative. And when you add, you get a negative 2. So a minus 3 is equal to 0. So a is equal to 3. or a plus 1 equals 0. A is negative 1. So a is 3 to the x. So 3 to the x equals 3. That's 3 to the 1. So x must be 1. So a is 3 to the x equals negative 1. So notice now, what power of 3 will give you negative 1? There's no answer. X, no matter what power of x you have, no matter what the x is, 3 to that power will never be a negative. Because if you remember, the base is positive, but the range or the y value coming out, it can never be negative. No matter what value for x you put in here, it'll always be positive. Okay, so the answer to this system, the answer is just 1. Okay. And another one to do. Again, I vary it. So this is a little bit different than the other one. I got an x plus 1. So let's change this to 2 to the x. Because this is added, that means it must have been a multiplier. So notice 2 to the x plus 1 is the same as 2 to the x times 2 to the 1. Again, look, when you multiply these two at the same basis, you add. So that means that 2 to the 1 is a 2. So there's 2 times 2 to the x plus 2 to the x equals 48. Notice now this is 2 to the x and this is 2 to the x. So that's a 1. That's a 2. So that makes it 3 times 2 to the x equals 48. Again, that's like a 2y plus y, which makes it 3y. Pretend that, or that's an a, if you let that be an a. So that's an a, so that's 2a plus a, there's the 3a. So I could let 2 to the x if I want, I could say let 2 to the x equal a. So that would be a 3a plus a equals 48. So that would be 3a equals 48. So either way, no matter if I just add these because they're just like terms. So if I have this, I just divide by 3. They cancel. I get 16. 2 to the x equals 2 is the base, 2 to the 4, x is 4. If I let 2 to the x equal a and get 3a equals 48, I divide by 3. And I get a is equal to 16. So a is 2 to the x, 16. 2 to the x is 2 to the 4. So if I let, again, 2 to the a equal a, you would go down this way. If you just added these because they're like terms, then you get 4 also. So that brings us to the end of the solving exponential equations part 1. And again, if you like my video, click the like button, click the subscribe button if you're not a subscriber. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content that I have on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video helped you. Bye-bye.